Hello. Today what we're going to do is look at making a publication quality graph in Excel. And in this particular case, this is the example where we took two different collections of data from our analog discovery 2s, and we have two saved spreadsheets. Now I saved them as comma separated variable format, the CSV. But when I make the graphs and do anything with any kind of formatting, that will go away when I save it as a CSV. So what I did, the first thing I did was I saved both of the spreadsheets, you can see them here, as XLS files, XLSX. So they are in the Excel format instead of CSV. That way when I make any graphs, they will be retained in the file. All right. So I have two files. One is positive in, out, and the other one is negative in, out. So what I did here was I could take two different channels at a time, and I needed to look at three channels. So I did the negative input on the op amp for the differential amp and the output, and I also have the positive input on the diff amp and the output. And what I'm going to do is copy the data from one to the other, combine the data so I have three sets of data, but first I'm going to be aligning the common signal from both of them. So the output is the same signal, but the timing might be a little bit different. So to make sure that they're aligned, I will show you how I will do that. All right, so the first thing I want to do is to take this data here. Here's our two channels and our time stamp here. And this is time in seconds, and channel 1, channel 2. To remember which one was which, I can look up here and see channel 1 was 100 millivolts per division, 0 volt attenuation, 1x probe. So this was 100 millivolts per division, and that was my, in this case, the positive input, and the output was at 500 millivolts per division, because when the signal magnitude got bigger when they were combined. So what I'm going to do is rename channel 1 and channel 2 as the input and the output, just to keep track of things. So I'm going to call this one V in plus, and that's in volts. All right, and then channel 2 was V out, also in volts. And I'll do the same for the negative input. Again, 100 millivolts per division, 500 millivolts per division. And we'll use that information a little bit later. So this one is going to be V in, this time minus, that's in volts, and then V out. And finally, I'm going to save this as a third file, and I'm just going to have a single file where I'm going to put both sets of data in. And let's save that as differential amp signals. Okay, so we're going to save a copy. I'm going to call it diff amp signals. Oops. Got it. All right, so I'm going to come over here to the other one, and I'm going to grab these two columns. So I'll just grab the whole column there, just clicking on and dragging across the 1 and the 2 and the 3 here, and then I'm going to right click and hit copy, and that's going to copy the entire column. And I'm going to go ahead and place that right here. So I'm going to go insert copied cells. And there we go. We've got the V in plus, the V in minus, and the V out. So actually I'm going to put a little bit of space here. So I'm going to insert a cell. I had two things highlighted, so I got two cells. But let's just go ahead and get rid of one. And this is just going to be the dividing line between one file and the next, just so we don't get confused. This one's saved, and I copied the data from this one to the other one, so I'm going to just go ahead and close that so I don't end up getting confused. And I'm working with this one. Alright, so the first thing we want to do is to set up a plot and maybe align this data. So let me zoom out just a wee bit so I have some more room. Alright, so I'm going to insert a plot. Now there's a lot of choices here. I'm going to use a scatter plot because even though the time steps are evenly spaced and a regular plot would do, what I want to do is allow for any changes. Usually when I plot data as data that I collected by hand, the time is, or the x-axis is not going to be regularly spaced for all the data points. And the way to handle that is to plot this as a scatter plot. Alright, so for this one, I am currently not interested in just symbols because this is a continuous signal that I'm going to be looking at. For discrete data points, we would use symbols instead of lines. This line smooths the lines between the points, and this line doesn't. So let's just pick this one for now, and we can always change back to that one. But this one will show us if our sampling was good enough. All right, so this is going to connect dot to dot. Now notice I didn't highlight anything yet. I'm going to start off with two sets of data, and let me just grab the first set here. So one way of putting in the data is to right click on this in the middle of the plot, and then I'm going to select data, and I could put in a chart range, but to have full control and not get confused about what's going on, what I'm going to do is just add a series. So for instance, this first one, the series name, let's pick the first two. So that's going to be that cell, and that way it'll put that label on the graph for me. And then the X values I'm going to use for time. Okay, so I'm going to start highlighting this, and then I'm going to go ahead and scroll all the way down to the end here, and then I'm going to hit Shift and then this last cell. Okay, there we are. That's my data. And now we need to do the Y values. We could do that the same way. And you see that this is showing that it's labeled by the sheet name, which is down here. And the range is goes from C1 to, where is that? So R35C1 to R8226C1. All right. So let's go ahead and grab the Y values. Or let me click on here. I want to get rid of that. So the Y values are the voltage, and we're going to do the same thing here. Okay. And I'm going to scroll down to the bottom, and then Shift and click and do that. Then I'm going to click OK. So we should have that data. Let's take a look at that. All right. And where did our graph go? There it is. All right, so that does not quite look like what we wanted. I'm not quite sure what happened, but let's go ahead and click on the line. It'll tell us what we actually have for data. And we look over here and we see for some reason I wasn't able to grab all the time. So what I'm going to do is grab this little square here. Well, leave that there. I'm going to grab this square. Let's grab that there. And I'm just going to pull this down. Let's see. I might be able to like double click on that. Nope. So this is kind of a brute force way. And you can see over on the right the scroll bar is scrolling. Alright. Might want to speed through this to get to the end. And I could show you another way of doing this in a second. Oops, there we go. Alright, so there we are. Let's look at the top now. And there we go. That's what we wanted to see. Okay. So let me hit Control Z to undo that scrolling that I just did. And that was part of it. So what I'm going to do now is just click to get the whole thing. You can see that somewhere down here I stopped. And didn't grab it all. Alright, but I know that the second column was good. So what I'm going to do is right click, select data, and then I've got this one highlighted. I'm going to edit. Alright, so the Y values were good. Let's compare. We start off with, let's see, so C1, so this is R34C1, okay, not quite sure what the R is, but this is 34C2, and that's where we are. Trying to, okay, I decoded it. So this is row 25, C, column 18. So this is our Y values are row 35, column 2 to row 8226, column 2. All right, so we want to see that these are the same numbers, so I'm going to change this one here to match the final row is going to be 8226. And see that the final row for this one is matching the final row for that one. Then I'm going to click OK, and let's look at the graph, and there it is. Okay, so the idea here is that you can, instead of scrolling down 8,000 lines, you can just type in the value that you want. And that value is the same over here. Okay, now we want to put in the V out, for instance. All right, same thing. We're going to right click, select data. We're going to add. And that's going to be V out. We'll just click on that cell and it'll populate it automatically. The X series is going to be the same as before. Let me cancel out of this so that I can grab that. So I'm going to edit this one, and then the X values are the same for both of them. So I'm just going to grab this and I'm going to copy it. Okay, now I'm going to add the new one, which is V out, and it's got the same time series. So I'm going to add that. The Y values, I can put the same thing in here again. And in this case, we've got the same rows, but we're going to start with column 3 and also end in column 3. And click OK. And OK. There we are. So that is our total graph. Okay, so the thing that we wanted to do was to align everything. Right, so what I want to do is plot the output here and the output there. So here's kind of a trick that I could do. Click on this one here, and I'm going to drag that over there, and look, we've got them shifted. Right? So that's not exactly what we want, but watch what we can do. Let me move this down. Oops. Grab this on the outside, move it down. Okay, so I'm going to start with the second data set, and if I just drag this down, you see that I'm moving it. And what I want to do is drag it down to a place where those are all together. They're getting closer. So I can zoom out. We're almost there. So we've got a little ways to go yet. One of the issues is we got a lot of data here, so we're just going to have to go with it. Almost there. Okay, now I've fiddled around with it for a bit and I've gotten it pretty close. If I want to, let me just kind of show you a sidebar on how to figure out how this is. Okay, there's this thing where I could like slide them over. I could do this in software and find them aligned really easily or straightforwardly. I wouldn't say necessarily easily, you got to write a program. But since we did this by eye and that we're well within one cycle of the output, which is the output frequency, which was 10 kilohertz in this case, what I can do is like sum a range of them, or actually find the difference of the range of them, and then I can figure out if the overlap is at the best point. And what I'll do is I'll just subtract the two, and the closest number I get to 0 is the offset that I'm going to need. Okay. Okay, so for the purposes of the lab, this is going to be plenty good enough. But if you want to be precise, let's go ahead and do this. So I'm going to look at the data again. So VN, that's the first one that we've got. It should be both V. Oh, I didn't change that. All right. So we're looking at column 6, row 373 is where it starts. Okay. And that's actually this one here. So let me fix that. If I do this, I'm trying to see if I can. One of the problems is that one of them is in front of the other. So let me, and when I click on, I'm trying to click on the blue one, and the blue one is behind the orange one. So what I'm going to do is I'm going to change the order so that I can get to them. So the V out here is starting at the first column, or 35 here, in the row 35. So if I click on this and hit select data again, I can change the order, and I just flop the order. I'm going to click OK, and now I can have the blue on top, and that is going to be V out over here. Okay, so that's in column 6. All right, so what we're going to do is select data, and we're going to look at That's column 3, which was the other one. Let's look at this one. Edit. All right. So this is row 35, column, or row 8226, column 1. 82, and I'm sorry, this is the number we're looking for right here. Row 373. That's where we started here. 373. Okay. Cancel. So let me just put that number here. 373 is first row of blue. Okay. And then the first row of the orange is at 35. So we'll go 35, first row of orange. Okay. Now what we want for an offset is the difference here. So I'm going to just take equals the big number minus the small number. Okay, so the difference between the two is 338. And that's the offset. Okay, so to check myself, I'm going to do a couple things. First, I'm going to subtract, for instance, this value here from the value at row 373, and then I'm going to do that for a range with an offset of 338 between all of them. And Excel will do all that offset stuff by itself, but I just wanted to show you that I'm going to be taking a range of values here and a range of values here that are further down, and I'm going to subtract them one to one, and then what I'm going to do is add them all up after I've subtracted the two signals. And if they are exactly the same two signals everywhere, then the total number, when I add up all the differences, should be 0. If it's not, then we can change our offset and see if we can get a closer value to 0. Right, so first of all, let's do that. I'll start over here so I get a little space. All right, so what I'm going to do, anytime I do an equation, I start with an equal, and I'm going to take this value, and I'm going to subtract from that hang on. Okay, so I'm going to come clean here and say that I am not familiar with this notation. This is called relative notation as opposed to relative referencing. But relative notation, or the R1C1 notation in Excel, I have never used this. The Excel file started out like this, and it automatically decided it wanted to do that. And I've never used it, but I figured it out. But I'm not quick with it yet, so I'm going to change it back. And to do that, I'm going to go over to File, hit More. I want to go to the Options. I want to go to Formulas. And here it says R1C1 reference style. That was checked for some reason. I guess Microsoft thought that I needed to learn how to use that. I don't want to do that, so I'm going to uncheck it. Click OK. And we're back to the usual referencing that we use in Excel. So this is C35. So all that stuff about the different columns and rows, it's going to simplify to just column C, row 35. All right, so there we are. That's, if I double click there, it highlights this. All right, so I'll come back up here. Now if I click on something here, it's going to automatically stick something in there. I don't want to do that. So what I'm going to do is C35, and I'm going to subtract. So this is from C35. I'm going to subtract. It's not going to be F35, it's going to be F373. So I'm going to change this. Like so, for instance, if I want to 37, it drops down to this one. Now if I hit 373, it drops all the way down to 373, which is the first row of the blue. Okay, so I just subtracted those two, and I get this number. Now what I'm going to do is I'm going to grab this corner here. I'm going to copy this cell. So what I could do is just hit copy, Control C, and you see the dotted line animates there. And then I can go ahead, highlight an area, and paste it. And the same formula is going to go in there. If I undo that, come on, Control X. Why is Control X not? I have to escape. I was in the editing thing. So Control X. Okay, Control X wasn't working. So Microsoft decided that I need to have some other kind of version of this Excel. So I'm going to see if I can figure this out. So instead of Control X, what I did was just highlighted what I did and I deleted it. All right. So what I'm going to do to continue this is I'm going to grab this and I can drag it, and it will drag that formula all the way down. So it'll continue. So what I'm going to do is drag this down. I'm not going to do the whole thing, but I'm going to grab a whole bunch of it. So let's just grab a bunch, let it rip for a little bit, and that looks far enough. All right, and that goes, let me bring it down to a nice round number. Let's go to 1600 so I can remember that number. All right, so basically all I've done is I've just taken a section of this graph, and from about here to, I don't know, maybe about here. And what I've done is I've taken the difference between these two. Now what I'm going to do is kind of sum all of those. So I'm going to equals sum to get into the equation and take the sum of those. And I'm going to start with that value, and then I'm going to hit the colon, and I'm going to go to H 1600. Now, if this is the right place to go, then I will have a very small number, and minus 1.7. Okay, so if I try to twiddle this around a little bit, 373, let's try 375, see if that works, and then I'm going to copy all this down, and that gave me a bigger number. All right, so Control Z, Control Z. Let me try something, 371. And enter, and then I'm going to click this first cell and copy it all the way down. And minus 0.36, that got me in the right direction. So remember, Control Z, Z as minus 1.8. Control Y, Y, minus 0.36. So let's go one more. 370. .32. Okay, so that was plus 0.33, Control Z, Z, minus 0.367. 0.33 was smaller, so that was closer to 0, so Control Y, Y. I'm going to use this offset. So that means that I should be starting at F370 instead of F373. And that'll give me a better match. So what I'm going to do is click on this again, and I'm going to scroll down to where this starts. Maybe. All right, I'm getting closer. There we are. And instead of starting at 373, I want to start at 370. So I'm just going to drag this whole thing up to 370. And that should give me a really good match for this plot. Okay, so now all of my axes are aligned, or my signals are aligned. So I've got these two signals now are aligned with these two signals, because I know these two are aligned with each other and these two are aligned with each other. So what I want to do is to now look at the three signals, the VN minus, the V out, and the VN plus. So what I'm going to do is I'm going to click here on this data, right? So this is the one that's been time shifted. What I'm going to do is slide that over to this location here, and then when I'm going to come down to where these are, and I'm just going to slide this over by one. Okay, now instead of looking at the output, I should be looking at the positive input. And that's what I got. Okay. So here's my input and that's the output. All right. So what's next? A couple of things. I've got more data than I need. And I've got X values, actually the time values, they go from 3 milliseconds to -3 to +3. I could get rid of a lot of this data just by starting at 0. And I don't like where the axis is here, and it's hard to see the axis when I move this. So what I'm going to do is click on the number for the x-axis, which is the time axis. And then I'm going to right-click and format the axis. And instead of starting at -3 milliseconds, I'm going to start at 0. And let's see what that looks like. So click off of that. All right. So we eliminated a bunch of stuff. All right, so let's look at this. This goes from 0 to 3 milliseconds, and we don't need all of that data. So let's go ahead and cut it off at 2 milliseconds. Whatever makes sense. And I'm also going to shift this down so that the axis labels are down here and the axis is up here, and I'm going to darken the axis. So I'm going to format the axis, and I'm going to change this to 2 milliseconds. All right, and I'm going to come down here to the labels. Yeah, this may be hidden, but I hit labels, and right now it's next to the axis. What I want to do instead is put it down low. Okay, so they're down here now. And I also want to darken up the x-axis, or the x-axis. So instead of the options for how things are laid out, I'm going to click on how it appears, and right now it's a gray color. I'm going to make it black, and I'm going to make it bigger. So 1.75 looks like a good 1.75 points. Looks pretty good. All right, so let's see where we are. And we see that we're showing this in terms of seconds, which is fine for the moment. And what we would like to do is now add the VN minus axis, or VN minus data. So we got the VN plus. So how do we know which ones we got? So let's go ahead and come over to the right hand side of when we highlight the plot. I've got this plus, so I can add chart elements. So I'm going to click on that, and the thing I want to add is a legend. Okay, and there's my legend. And I generally like to have it on the graph, and let's move the graph over. And a lot of times you got the grid behind it and we don't want to see the grid. So what I'll do is I'll right click on the edge of the box and give it a fill, and I'm going to use white. Now if I want to, I can do whatever color I want. Transparency, sometimes I'll give it a slightly transparent so you can see the grid behind it, but it is very dim. Okay, so there we are. The grid line is there, but it's a lot lighter. Okay, so let's add the next line. So we're going to go right click and then select data. I want to grab the range. So first I'm going to edit this. I'm going to use the same time values for everything. So I'm going to copy this. And then I'm going to add one. And I'm going to put those time values here. And for the y-axis, I'm looking for column B. So I'm going to type that and change my A to B. I could do uppercase, lowercase. It'll change it to uppercase when we're done. And notice that we've switched over to the notation. Before we were in the R1, C1 notation, now we're in the A1 notation. So instead of the relative notation, we know that we're in column A, row 8226. Okay, so we want to, that should be a B, right? Then we're going to come up here and we're going to click that. So we've got time is A and the values are in column B. Click OK. Okay. All right. So you can kind of see it's a gray line. Just for now, we'll right click on that and we can change the data series, we format it and click the colors. I don't like that color, so let's just pick red for now. I'm not going to do too much more with that, but let's just go with that. All right, so here we are. Here's our stuff. So we have V out, Vn plus, Vn minus. Okay. If we wanted to put the V out on the bottom, what I could do is come over here, right click, select data, and just highlight the one I want to move, and I can just move it down in the order. Click OK, and then I got plus, minus, and output. All right, so we're looking pretty good. Not quite there yet. So let's add a second axis. What we would like to do is have the output be on one axis and the inputs be on another axis, so I can show you how to make the output about the same range of sizes visually as the inputs. In this case here, you can see that we've got this small signal that's going up and down, and we've got a faster one. And when I take the difference between them, what I will do is take the difference and then I will amplify that difference. And that amplified difference is up here. Remember, the amplification factor was 10, so that the difference between these two is going to be 10 times bigger, or this orange is going to be 10 times bigger than the difference between these two. All right, so let's add that second axis. Okay, this is pretty simple. So what I want to do is to pick one of these to put on the secondary axis. So the output, I want to put the output axis on the right side and have the input axis over here. So what I'm going to do is I'm going to click on the output signal, right click, and then format the data series. And usually you pop up this and you got all those different format options, but if I come over here to the series options, I can select the secondary axis. So for this data, I can put the secondary axis there. Okay, and that does it. All right, so now I have this axis is the secondary axis. This is the primary axis. And if we wanted to put more data on it, like say for instance we wanted to put this axis on there, so format data series, put that on the secondary axis, and it puts it on the secondary axis. But we don't want to do that, so I will undo that. And there we are. Okay, so we see that the output is like this and the input's over here. All right, so now we're starting to get ahead of ourselves. We've got labels on our axes. You always need to label your axes. Don't always have a secondary y-axis, but we need to add labels to these. So come up here and I want to add axis titles. Always, always, always have axis titles. Okay. So you can see the axis titles popped up, and simply all we need to do is just click on them and then write down what they are. So this is output signal, and that's in volts. Anytime you have a unit that you're using, then we'll put that unit in there. Okay, so it's output signal in volts, and over here we're going to put the input signal in volts. Signals in volts. All right, there we are. So one of the things that I like to do is to change the fonts around a little bit. I want to make room for my lines here, and I'm going to do that first by just selecting the inner part here. Let me get it just on that piece here, and I want to make this smaller. Okay, and I'll move this a little bit smaller. So I've given myself some room on the sides here. I prefer to use Arial, so I can click on the larger graph all by itself, and what I can do is go to Home, and instead of using Calibri, I'm going to use Arial. And Microsoft likes to have the low contrast gray things. I'm going to change those to the font to be black so it's more readable. And I'll stop there for the moment. Then I'll go back to this title, and we see that it's 10-point font, and I'm going to increase that to 12 points, and this one to 12 points. Could go as high as 14. Yeah, 14 looks better. So I'm going to go to 14. All right. So I haven't messed with the axis title over here, and let's make room for it first. Move that whole thing up a little bit. All right. So this is going to be time, and that's going to be, right now it's in seconds, and I want to use milliseconds. So let's use milliseconds instead here. All right, and again, I'm going to increase this one to 14-point font. Okay. Now what I want to do is to make these numbers milliseconds. And the way that I'm going to change those to milliseconds is I'm going to go back here, and these are time in seconds. So what I'm going to do is I'm going to add a column, and then I'm going to add time in milliseconds. Then what I'm going to do is take whatever this number is, so an equation, you'll equal that number, and I'm going to multiply it by 1,000. Okay, so this is in milliseconds. I'm going to come over here and double click that box to populate everything. When I double click the box, it will populate everything down to where this line of numbers ends. So I'll just double click there. So like if this had a gap here, and let's say line 47 wasn't there, when I double click there, it would go down here and stop at that 47. All right, so what are we doing here? So let's take just this time in milliseconds. So this could get a little squirrely. Hopefully we can do it this way. And all I'm going to do is take my line here and drag it here and see what happens. Okay. Looks like it went away, but let's not worry about it yet. Let's do that for all of them, all three. And then we're going to go back to this one, grab that, and move it over. Okay. Now I'm going to go to the format the axis, and this is going to go from 0 to, we want the 2 milliseconds, and there we are. Okay. So this looks like the same graph, but now we've got the time in milliseconds, and they're much more readable numbers. Okay. Okay, now let's look at this data here. It looks kind of crammed together, if you will. First thing I'm going to do is take the input signals, and I'm going to rescale the axis here. So now I'm going to click on the x-axis, and I'm going to format the axis. And this goes from minus 0.15 to plus 0.15. So what I'm going to do is change that from minus 0.2 to plus 0.2. All right, and we see that it has shrunk that down a little bit. And this is also going to give us the visual that things are being amplified. All right. And let's see, the 2.5 works pretty good. So let's change this to 0.25 instead. I'll mention why in a second here. And this kind of makes sense because our gain on our amplifier is 10. So we can see when we add these together, so for instance, let's take this, we want to have the largest difference, so, and we have the input minus the output, and the input is the blue, the plus is the blue, so we're going to take the blue, or we're going to look for, let's go look for this minus thing here. So we're going to take this blue minus the red is going to give us a negative number, and we're going to multiply by 10, and it's going to get here. So the negative number would be, the blue is minus 0.1 here, and we're going to subtract 0.1, so it's going to be minus 0.2, which is right here. But the axis over here is 10 times higher, so it shows that we've scaled the result by 10. Okay. All right. What else can we do? The colors are kind of wonky. So what I'm going to do is I'm going to take this output signal, and I'm going to format that. And I'm going to format the colors, how it's presented. This one I'm going to make black. And I'm going to change that to, let's try 2-point font. That seems pretty good. Okay. Can even go a little higher. That looks pretty good. All right, so now let's look at this signal here. That one's blue. What I'm going to do is I'm going to leave it blue, but I'm going to make it a darker blue. Let's go with that. That's maybe too dark. I want to allow the color to be a little bit different, but I also want to, let's change that to 2-point font, 2.25. Yeah. And what I want to do is look at a different input, so I'm going to do dots for that one. Okay. We could try different ones. We can try the squares. Yeah, I kind of like that. So let's drop that back a little bit. And then my other input, so that's a blue input. I want to use a deeper blue. Go to more colors and go to the standard colors, and I like that one there. That's pretty good. Okay, change it to that color. Now let's do the same thing for the red. The red, I like the color. Let's go up to 2-point font again, and I'm going to make that a dash line. That kind of looks the same. So let's make it a longer dash. Okay. If we wanted to, we could do a long dash dot. Okay. Yeah, let's do that. And then we can play around. So what we're trying to do is separate them visually two ways. One is with color, but we can't just point to the color, because if this is printed in black and white, or if the person reading it is colorblind, they won't see what it is. So what we're going to do is change the type of line here, the dash type. Let's just do a dash here for this one. I don't like that. If I do a long dash, that's better. But if I do these short dashes, I think I'm going to stick with the short dashes. All right. So this is already getting pretty crowded, but there's enough information on that. And we could also like offset things too. But we've got our lines, and we're pretty close to what we want to be, where we want to be. So let's move our key over to someplace we can see it better. Let's open it up a little bit. I was hoping that would make the line a little bit bigger, but let's not worry about that. So this is a legend that tells us which signal is which. And I think we're pretty much done here. One thing I do notice is the overall thing has a border around it. Let's get rid of that border. So I'm going to say no line over here. And that way when I copy and paste this into like a PowerPoint document, things will look pretty good. I do want to put a border around the outside of the plot area. So the plot area options, I'm going to put a solid line, and I'm going to make that one black. And that's going to frame it nicely. These two axes, I want to do a solid line, and we're going to bump that up to the same as the other axis. So those were 1.2, black line, .25 font. This is 1.75, so let's change them all to 1.75. We're going to be consistent. Okay. So I'm going to take this guy here, I'm going to drop it down a little bit. Seems too dark. All right, that's good. And we can experiment with these other ones too. The red line looks pretty good with the dash dot. The blue line, yeah, it gets kind of big. So what we're trying to do is find a happy medium where the signals are unique, they kind of stand out by themselves, and life is good. All right, so this one's a little cluttered. We might be able to change things up a little bit. So for instance, if we only look at one cycle, we'll go to 0 to 1 millisecond. And for instance, let's go to this and see what that looks like. If I change this to 1 millisecond, what does it look like? Okay, so that's pretty good. Let's change it to 1.5. That looks pretty good. I think I'm going to go with that. So 1.5 milliseconds looks pretty good. I'm going to take this, pop it up here out of the way. There we go. So that's a pretty good looking graph. And this would be acceptable for a publication quality graph.